Hey guys, today we are going to go in the opposite direction of what we did the other day. So the other day we were graphing sine graphs or sine functions. Today we're going to look at a graph and we're going to determine what that function would be that would create that graph. Okay? So for example, first thing we're going to do, we're going to look at this shape right here. And the first thing we want to determine is what kind of function is it? Well, notice that this graph goes through the origin, and then it goes up from there and down. This is a sine graph, okay? Cosine graphs start at their high point. Sine graph starts in the middle and then goes up from there. Vertical shift. This graph starts right here. It goes up to 4 and it goes down to -4. So there is no vertical shift. So that's going to help us. What is the amplitude? All right, well, again, if we start here and we go up to 4, that means that's what our amplitude is, okay? So remember what we're trying to figure out. We're trying to figure out y equals a sine of x and plus h. Okay, so we're trying to figure out this information and how it's going to go into here. And that should have a k in front of the x. Sorry. Okay, don't want to forget the period, which is the next thing they're going to ask us here. Okay, so what we're doing is we're just trying to figure out the blanks to fill in here. What numbers to throw in, okay? That is going to create this shape. So the period. Now, period is the width of a cycle. So if this is where my graph is starting, think of what a sine graph does. It goes up, it goes down, and then it comes back up to where you started. This is the end of the cycle, okay? They've drawn extra graph here. We don't need that. We just need to know where it starts and where it ends. This is 2 pi, this is 6 pi, this would be 8 pi. That is the period, 8 pi. Now, that is going to find us our k value. It's not the k value. This is not something that's going to get plugged into this equation. Remember, the period is 2 pi over k. And in this case, our period, or this formula, is equal to 8 pi. So now I just need to solve this for k. So I'm going to cross multiply. I'm going to move the k over here. So that's going to be 2 pi equals 8 pi k. And then I'm going to divide by that 8 pi that's in front of my k. So if I divide everything by 8 pi, this cancels, and it would leave me with 1/4. So k equals 1/4. So that's the k value. So if I take this equation, this is a sine graph, and I plug in the 4, and in this case the 1/4, there is no vertical shift to plug in, I'm done. Y equals 4 sine of 1/4 x, and that is the equation that is the graph of. Okay? Let's look at the next one. So, first thing, what function is this? You're always going to ask yourself this. Well, if I look at the y-axis, this graph, here's its starting point. It's starting at a low point. So that's what a cosine graph does. It either starts at the high point and then ends at the high point, or it could start at the low point if it's been flipped, which we'll talk about in a second. Okay, but first things first, this is a cosine graph. What's the vertical shift? Again, this graph goes down to here, it goes up to here. This says 5 halves. Okay, so this is 5 halves, this is 5 halves, so what's that, like 2.5? Okay, they're the same, so there is no vertical shift. Again, our graph is going, this is the middle of our graph. The middle of the graph, the midline, and the x-axis are the same. So there's been no vertical shift. What's the amplitude? Well, this graph starts at -5 halves. So the amplitude, the actual amplitude is 5 halves. Okay, 5 halves. But this has been flipped. Okay, a normal cosine graph has been flipped upside down. So there is going to be a negative out front when it comes to writing our equation. But again, technically the amplitude is the height, which would be just the 5/2. Okay, now what's the period? Again, you need to know the width of the graph. One cycle. If this is where the graph starts, at this low point, then one cosine graph will finish at this low point. So that's it. So what is this? That's 2. It's just the number 2. All right, so that's the period, 2. But the formula for period is 2 pi over k, and that formula, in this case, is equal to 2. So we just need to solve. So we're going to cross multiply. That'll give us 2 pi equals 2k, which you probably will see these 2's are going to cancel each other. So k is equal to pi. Okay, so that's it. So we're going to take our normal equation, y equals, we're going to plug in the amplitude, negative 5/2. We're going to type in the function, cosine, and then we're going to plug in our k value, which is pi, pi x. That's it. That is the equation that is the formula of. Okay? All right, last one on this page. So, how about this one? So first off, what are we dealing with? Well, we're obviously dealing with a graph that's been shifted. Okay, so that's the first thing let's take a look at. Here is where the graph crosses the y-axis. So this is my middle, my midline, the middle of the graph. So if you were to pretend that this was the x-axis, notice what our graph does. Our graph goes through the middle, and then it goes down, and then it goes back up, and then it goes down again. It's right here. So, first off, what kind of graph is this? This is a sine graph. It starts in the middle. It doesn't start at the high point, doesn't start at the low point. It starts in the middle. So this is a sine graph. Vertical shift. Well, sine graph usually goes through the x-axis. So since it's going through this point, which this is negative 1/2, this is negative 3/2, so this is negative 1. That's our vertical shift. So this graph is going down 1. So that's going to be at the very end of our equation. That's our h value. Okay? What is the amplitude? Well, this graph goes from negative 1 down to negative 1.5. So that's the amplitude, a half. Again, this goes down first. So this normal sine graph has been flipped upside down. So it is going to have a negative when we go to write the equation. So if you want to write it there, that's fine, but still understand that the amplitude is a positive value, but this one's been flipped. Okay, what's the period? Well, again, that's this overall width from here to here. Don't look at the end of the graph. This is nothing. This is the start of a second cycle. We don't need that. We just need to know where the graph starts, where it finishes, and that is at 4 pi over 3. 4 pi over 3. So I'm going to go over to the side here. I'm going to set 4 pi over 3 equal to our formula, which is 2 pi over k. All right, so I've got a fraction equals a fraction. First thing I'm going to do is I'm going to cross multiply. I'm going to take this k times the 4 pi k. I'm going to take 3 times 2 pi, which is going to be 6 pi. All right, so let's see what's going to happen. First off, notice these pi's are going to cancel. You got a pi on both sides. And so now the only thing in front of the k is a 4. So I just need to divide everything by 4. Now, don't leave this. 6 over 4 is 3/2. So 3/2 is my k value. All right, so now I'm just going to take a normal equation. So y equals a sine kx plus h, and I'm going to plug these values in that we found. Okay, so the first thing we know we plug in is the amplitude, negative 1/2. Y equals negative 1/2. Then we plug in the function. In this case, it was a sine graph. K, what do we find? 3/2. All right, so we're just going to put a 3/2 in front of the x. I usually put parentheses and close that off because now we're going to put plus something. Well, in this case, we're actually going to put minus something, minus 1. And that's our h value. And that's it. So you're just going to look at the graph and piece by piece figure out the different parts and what's going on with the graph, and then we're going to put all that together into the equation. Okay? All right, so what we're going to do is we're going to take that information about how to take a graph and create an equation out of it, and we're going to look at some like word problems. Okay, so look at the next example. It says the tide in a coastal city peaks every 12 hours. So the water in the ocean, there's tides, right? So you've got high tides, you got low tides. So the water level goes up and the water level goes down. And this happens in, don't think of like when you talk about sine wave or a cosine wave, don't think of like the waves. It's the fact that the tide is going to rise over a certain period of time, and then it's going to go down. And then that's going to repeat. It's going to go up and it's going to go down. So over time, you're going to get something that looks like a sine graph or a cosine graph. Kind of depends on where they start you out in the problem. So take a look. So the tide peaks every 12 hours. The tide ranges from 5 meters to 1 meter. So 5 meters, that's the high tide, and then 1 meters, that's the lowest it's going to be. Okay? Suppose that the average tide level, which would be 3 meters, occurs at time equals 0. Okay, so here's what they're saying. If we were to look at a graph, and everything's positive here, 5 to 1 and a 3. So I'm going to kind of draw my graph a little heavy on the high side there. Okay, and it says it peaks every 12 hours. So here's 12. And we'll call that 6. And we'll call that 3. And we'll call that 9. Okay, so again, we're going to take our graph and we're going to, however long we need it to be for one cycle, we're then going to cut that in half, and then we're going to cut it into quarters. Okay, so that's what our x-axis is going to look like in this problem. The tide ranges from 5 meters to 1 meter. So we need 1, 2, 3, 4, 5. So there's high tide, there's low tide, and there is our middle, our average. Now, the problem says that the middle, that average tide is at time equals 0. So that's the beginning of our graph. So that means our graph is starting here. Okay, then from here, the graph is going to go up to a high tide of 5. It would then, now I'm going to go ahead and draw this little dotted line. Okay, that's our midline. That's our average. Okay, because at the next time, which would be 6 hours, we're going to hit that midline. Then we should be down at our low of 1, and then we should be back up to 3. So this is what our graph of the tides are doing. Okay, so once we have a picture, now we're doing just what we did on the previous page. What function is this? Well, it starts in the middle, goes up, down, and up. So this is a sine graph. What is the vertical shift? Well, normally we're at the x-axis, and now we're at 3, so that's our vertical shift. So plus 3, up 3, that'll be at the end of our equation. What's the amplitude? Well, this is 3, and that's 5, so that's a difference of 2. Okay, once you got a picture, you can kind of whip through this pretty quick. What's the period? This is the one where you got to stop and got to do some math. Okay, so the period. What do we got here? We have an overall width of 12. Now, that's the period, but that's not what we're going to use in our equation. We need to figure out what k is. So 2 pi over k equals 12. So if you cross multiply, it'll move the k up here. So 2 pi equals 12k. And then you would divide by the 12 and get 1/6, or pi over 6. Nothing's going to make the pi go away. There's nothing to cancel that. So it's going to be 1/6. So k, it's pi over 6. That's it. That's everything we need. Y equals, what is the amplitude? 2. What do we need next? Sine. Then we need our k value, pi over 6. Pi over 6x. And then we need our vertical shift, plus 3. That's it. That is our equation. Okay? Now, another little question here says, determine the height of the tide at 6.2 hours. Okay, so what would the tide be at 6.2 hours? Now, all you would do is, what they're saying is, when your x is equal to 6.2, so that's our x-axis, 6.2, what would your y value be? Okay, so see what happens if you plug 6.2 in for x. So you could grab your calculator and plug that in and see what happens. Now, before you do that, notice that we're dealing with radians here. So if you're going to plug this in your calculator, you need your calculator to be in radian mode. Okay? So I've got one example of a calculator here. This has a little, it says DRG. This is degrees, radians, and then something called gradients. So what you want, there's degrees, there's radians. So you want to be in what's called radian mode. In the other TI that most of you have, there is, I think you have to shift and then hit this. So see if you can see where it says DRG, and you may have to shift to be able to get to it. But you want the top screen to say rad instead of degree. Then, once you plug things in, it should work. Okay? So try that and see what your answer is. Alright, so I did it, and I got 2.79, okay, which makes sense, and it looks with our graph. If you look at the graph, at 6 hours, we're at 3 feet or 3 meters, and so a little bit past that, it should be a little bit lower. The graph's going down there, so 2.79. Okay? All right. So what you can do is, once you have a graph, you can use that graph, or use that function, okay, to kind of make predictions about what you think is going to happen or what's going to happen in the future. Okay? So if you look at this next one, it says the data represents the average monthly temperatures in Denver, Colorado. Use the data to find a sinusoidal function that models the data. All right, so this is 2 years of data. They've given us 1 year, okay, over here in this column. So they've given you January 1st, 29.7, so there's the low. And then the graph, the temperature is going up, 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 to a high of around 73, and then it starts to go down, 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 down again. Okay, so here is our graph, and this would be one cycle. Okay, so it starts at a low and it ends at a low. So first off, this is a cosine graph. That's the first thing you want to know. Now, what's the vertical shift? The vertical shift, you need to know where the middle of the graph is. Okay, so for this one, let's take our high temperature, so that's our high, and let's take our low, and let's average them, and let's see where the middle is. Okay, so I'm going to take 29.7, I'm going to add 73.5, and then I'm going to divide by 2, and I'm going to get 51.6. So here's 30. What's this counting up by? 5s? 35, 40, 45, 50, 51.6. 51.6. So that is my midline. Okay, we're going to call that our midline. So that's our vertical shift. Instead of the x-axis, we've shifted up 51.6. All right. Now, what's the amplitude? Remember, the amplitude is how high your graph goes from the midline. So let's take that high value, that 73.5, and subtract our midline and figure out what that difference is. So, again, it's 73.5 minus the 51.6 we just found, 21.9. 21.9. So that's our amplitude. Okay, what is the period? Well, again, the period, one cycle is 12 months. Just like in the other problem, it was 12 hours. So again, we're going to get a k value of pi over 6. Okay? Another thing, when you were using your calculator on the last step, if you couldn't figure out how to change it into degrees, or how to change your calculator into radians, I guess you also could have changed that angle into degrees, because pi over 6 is 30 degrees. And then if you would have just plugged a 30 in, with your calculator in degrees, you'd have been fine. Okay? So this is everything we need. So what is our equation? Y equals 21.9 cosine pi over 6 x, and then a vertical shift of 51.6. That's it. That's our equation. All right, last thing we're going to talk about today. We have talked, when we've graphed equations, we have taken them and we've stretched them vertically. That's the amplitude. We've talked about how you can shift them vertically, so take the whole graph and shift it up or shift it down. We've actually talked about stretching them horizontally. That's the period. You don't notice that as much because we just do it by changing the way we label the x-axis, so they all kind of look the same, no matter how wide the graph is supposed to look. But the one thing we haven't done is we haven't done what's called like a horizontal shift, okay? And that has its own name when it comes to sine and cosine graphs. It's called the phase shift, okay? So that's the last piece of the puzzle we're going to put today. So phase shift is going to add one thing to our equation, that little minus c right there. So we already know the a, we already know the k, we already know the h, so those are not going to change. C, this c is called the frequency. That's not something we're going to talk a whole lot about. What you need to know is this, how to find the phase shift. So the phase shift is a formula. It's the c value. Now notice there's no minus here. That minus is part of the equation. So if you see a minus, like a -2, then that c is just a plain 2. But if you see a +2, remember there's supposed to be a minus there. So it would be, if you see a plus, it's because it's really a minus negative, and they've let the two negatives cancel each other out. Okay? So the phase shift is our c value divided by our k value. So just like there's like a little mini formula to find k, there's going to be a little mini formula to find the phase shift. Okay? So let me show you how to do one of these. It's going to add one little tweak to how we do our graphs, but I don't think you're going to have a whole lot of trouble with it. So look at the first one. So I've got 3 sine 2x minus pi. All right, so what do I know here? I know it's a sine graph. So sine graphs look like that. Okay, I'm just going to be thinking about that. I know the amplitude is 3. I know my k value, well, so remember, or the period, excuse me, the period is 2 pi over k. Well, the k is a 2, so it's going to be 2 pi over 2, so it's going to be pi. So that's the period, pi. And then I know that this graph is going to have a phase shift of, well, so remember, that minus is part of the formula. So it's the opposite of what you're looking at. So it's just the positive pi value, not the minus pi. So it's pi over 2. Pi over 2. So here's what you're going to do. Just make a normal graph. Now we're just going to do one cycle. So I'm going to go out to pi. That's what I need my period to be, is 1 pi. So I'm just ignore the phase shift for a second. So that's a pi. That means that's pi over 2. That means that's pi over 4, and that's like 3 pi over 4. Okay? That's important. Amplitude is up 3 and down 3. Okay, so that's 3 and that's -3. Now, the x-axis is very important. It's a normal x-axis. We went out to pi, we cut it in half, we cut it into quarters. But our phase shift is pi over 2. So our normal sine graph is going to shift over here to pi over 2. It's going to shift 2 of these increments, our little intervals. So instead of starting at the origin, we're going to start here. And if I needed to shift my starting point by 2 little increments or intervals, that means the end of my graph is also going to have to stretch out. So I'm going to take my normal graph and I'm just going to add 2 more increments. That's where my graph is going to end. My graph is going to start here. It's going to go up to the high point. It's going to come back down to the x-axis. It's going to go down to the low point, and then it's going to come back up to the x-axis. So this is my graph. Only draw one cycle, because sometimes when you draw a second cycle, it's hard to tell where did you actually start. Did you shift it to the right like you're supposed to? Did you accidentally shift it to the left? So we're just going to draw one cycle on these so that I can clearly see the shift. Okay? So that's it. So this is pi over 2. This is pi. This would be like 3 pi over 2. That's where this graph starts and ends. Okay? Take a look at the next one. I've got a cosine graph. So again, at the very beginning, I'm thinking this. That's cosine. So what do I know about this cosine graph? I know it has an amplitude of 2. The period is going to be 2 pi over k, but the k is a 1, so it's just going to be 2 pi. So right now you could draw our graph, our like x and y axis. Our graph is going to go out to 2 pi. That would be 1 pi, and that'd be pi over 2, and that'd be 3 pi over 2. Okay, if that's 2 pi, that's 1 pi, that's pi over 2, and that's 3 pi over 2. Now, this graph has a phase shift. Oh, I guess I could also do the amplitude up 2 and down 2. Phase shift, remember, it's the opposite of what you're looking at divided by the number in front of the x. But in this case, it's just a 1. So it's just going to be negative pi over 2. So that's our phase shift. So first off, what is pi over 2? With our graph that we made, what is pi over 2? Well, that's pi, that'd be pi over 2. So pi over 2 is one of these little increments, these little intervals that we've divided our x-axis into. But we want to shift left. We want to go in the negative direction. Okay? So I'm just going to come over here. I'm going to go left. That's what that would be. That's negative pi over 2. If that's positive pi over 2, that's negative pi over 2. And that's where our graph's going to start. This is a cosine graph, so we're going to start at the high point. Once you have that starting point, then it's just move to your right and do what a normal cosine graph does. It comes down to the x-axis. It goes down to its low point. It comes back up to the x-axis, and then back up to its high point. This is one cycle of that graph. Okay? Has a domain, you know, I didn't ask you about like domain and range, but again, domain, all real numbers. The range goes from 2 to negative 2, something you can clearly see once you've got the graph. Okay? All right. Let's take a look at the next one. So, cosine, that negative is jumping out at me. Okay? So this is a cosine, but it's going to look like that. Okay? So I like to kind of think about these before I start graphing them. This has an amplitude of 3, but it's flipped. It has a period. So what's the period? 2 pi divided by k, which is negative 4. So 2 pi, let me go ahead and just write that. 2 pi over negative 4. The 2 and the 4 will reduce, and you'll get negative pi over 2. That's our period, negative pi over 2. So that means this graph goes the other way. Okay? It goes this way. So this, if this is where the graph starts, this is where it would end at negative pi over 2. So that'd be negative pi over 4. And then I'm going to cut those into quarters. All right, that's okay. So this is kind of a, this kind of is going to have a vertical flip, but it's also got a horizontal flip. That's what's going on there. That's a horizontal flip. It just changes the period, makes the period negative. Okay, so just draw it in a negative. We're going to draw it from right to left instead of left to right. All right. Now, it's got a phase shift as well. So let's take a look at that. Remember, it's the opposite of this divided by this. So negative pi over negative 4. So that's going to be pi over 4. So our phase shift is positive pi over 4. So let's figure out what the heck that means as far as our x-axis goes. Here's negative pi over 4. It's 2 increments to the left. So I just need to go 2 increments to the right, and that's pi over 4. So that's where this graph's going to start. Remember, I said it's going to go from right to left, but this is the rightmost edge of our graph. Now remember what we're drawing. We're drawing a cosine, that has a negative amplitude. So it's going to start, so 1, 2, 3, up, 1, 2, 3, down. This is where the graph's going to start, right there where my 4 is. Okay, so pi over 4, down to negative 3, that's where my point's got to be. I'm just going to make it great big, and I'm just going to wipe out that pi over 4. All right? Then just draw a cosine graph. What's cosine do? It goes up. Then it goes up to its high point, which is, oops, ooh. You see what I did? I skipped over my increment here. So ignore that for a second. Here's what I should have done. I should have went up to the first increment. You probably did it right. You weren't even paying attention to me. Then you go up to your high point, then down low, and then down to your low point. And you get this really tall, skinny looking graph. And again, it's skinny just because of the way I drew it. If you made your graph bigger, it may not look as skinny as mine. But, so that's why it's important that we label our x-axis so that we can see that we're all drawing the same thing, even if our graphs don't look the same. Okay? Tell you what, why don't you pause the video, try D, and then play the video and see if it's right. Okay? So hit pause. All right, so I'm going to go and take a look at from this point. So I found all my information, the amplitude, period, and phase shift. Okay? And then I went ahead and made my x and my y axis. I went ahead and labeled those. So that now I can kind of take a look at, so the period was pi over 2. So there's how far we went. But the phase shift is negative 3 pi over 4. So negative 3/4. So first off, what does 1/4 look like? Here's 1/4. So if I go to the left, that'd be negative 1/4. I had to go 2 increments. Okay? But then I'd have to go another 2 increments. That'd be negative 2/4, which we would normally write as pi over 2, not 2/4. And I need to go further. Another 2 increments. That's negative 3 pi over 4. So that is where this graph is supposed to start. Okay, that's okay. Once you get your starting point, then it's just a matter of following the x-axis and putting all your points in. This is a cosine graph that's going to start at its high point. So I'm going to come over here to this negative 3 pi over 4. I'm going to go up 2 to the high point. And now I'm going to come down to the x-axis. I'm going to go down to my low point, up to my x-axis, up to my high point. That is my graph. That's it. That's the first cycle, is way over there. Okay? Last thing we're going to look at real quick is what if I gave you information about a graph and then asked you to graph it? So first off, I'm going to write down y equals, now these are all sine graphs. I'm not going to try to trick you with that. So sine graph, so a sine kx minus c plus h. Notice on the graphs we did, I didn't do a vertical shift. I could have, okay, and so we would have just went up 2 or down 2, and we would have drawn that midline and just based everything off of that, okay? This problem as well does not have a vertical shift, but if I did, you would just put a plus 2 on the end of the equation, okay? Amplitude is 2. All right, y equals 2 sine of, well, I need k and I need c. So k comes from the period. So I'm going to take the period of pi, I'm going to set it equal to the formula for period, and I'm going to solve for k. I'm going to cross multiply. K pi equals 2 pi. The pi's will cancel. K equals 2. All right, 2x. Now I just got to figure out what my c value is. Now remember, the formula for phase shift, which in this case is a negative 2, is itself a formula. It's c over k. But I know k. I found that in the last step. So c, the thing that I don't know, over k, which I do know. It's 2. And a simple little cross multiplying gives me a negative 4. So there you go. Minus negative 4. So plus 4. And that's the formula. Okay, so we can do that as well. We can write an equation given all this information, including this new thing we found, which is phase shift. Again, it's just a little bitty math problem you got to do to figure out what your c value is. I'm not giving you the c. Okay, that number did not get plugged in. I used that number in the formula to find c. Okay, so take a look at your worksheets, your homework, and then let me know if you have any questions. Thanks.